So far, we've discussed two different types of scope, global scope and local scope. Indeed, those are the most common types of scope that we have to deal with, and Python has rules of precedence over which type of variable is called first in the event that there's more than one reference to a particular variable name. And that ordering is sometimes referred to as an Legb ordering, where the Legb acronym stands for local scope first, then enclosing scope, then global scope, followed by built-in scope. And the picture that helps us understand what can be accessed from where is over here on the right. What this acronym means is we can imagine, and we'll have an example in a moment, having up to 4 different occurrences of a variable name. At any moment in time, when we try to reference that variable name, Python is going to give first precedence to the local variable that happens to have that variable name. And in other words, if you'd like to think in your head of an example of local scope, you can think of just defining functions, as we've already seen. In the event that there is no local scope variable with a particular name, Python will divert precedence to enclosing scope variable names. We haven't yet seen a true example of enclosing scope, but we will see one in just a moment, so we'll talk more about what that means shortly. If there is no variable with enclosing scope involved, Python will search all variables with global scope for the definition and the value of that variable. Global scope are all of the variables defined within our main program. And last but not least, Python will give precedence to built-in scope. Built-in scope we haven't yet discussed in these videos, but we have seen examples of words that have built-in scope, which we'll discuss on our next slide. So in these 16 lines of code, I've created an example to highlight not only what these different types of scope are, but the precedence that's given to them when we write a program. To begin, we create a variable with the name of x, and we assign a value of 0 to that variable. This is occurring all within our main program, and so this particular x has global scope. It should be accessible throughout all of our program. Beginning on line 5 is the definition of a function that we've called outside. Within this function, we are also free to define a variable whose name is x, and this variable x will hold a value of 1. Because we are making that definition inside of a function, this variable x has local scope. Where we start to see an example of enclosed scope is if we were to define a function inside another function. And that is the sense in which this function and its variables are enclosed. They're enclosed within another scope. So inside of the outside function, we make a function definition, and we're also free here to create a variable called x and assign it a totally different value than the other x's we've seen thus far. So at the point of line 11 in our code, we have 3 different variables with the name of x. The variable x on line 2 is our global variable x. It has a value of 0. Our local variable x is defined on line 7 and has a value of 1, while our enclosed variable is defined on line 11 and has a value of 2. Following each variable declaration, I've added a print function so that at the time the flow of control finds this variable, we will print its value to the screen so we can understand better which x is being referred to when we call the print function. Following the blocks of code that we see in lines 1 through 16, the flow of control for our program starts at line 2 by declaring this variable and giving it a value of 0. Flow of control then moves to line 3, where we print the word global, followed by the value of x. At this point in time in the code, there is but one x, the one that's declared on line 2, and so what should be printed in line 3 is the number 0. Flow of control then skips all of the function definition until it is needed and proceeds to line 16, where we call the function that we've defined on line 5, calling the outside function. So far a flow of control has gone to line 2, to line 3, straight to line 16. Upon calling the function in line 16, flow of control begins executing in the body of the function. So our flow of control jumps up here to 5 and down to 7 immediately, where our second instance of a variable named x is created and assigned a value of 1. When our flow of control moves on to line 8 in this program, we now need to print the word local followed by the value of x. Because local scope has a higher precedence than global scope, the x that is printed here will be the local x, and we should see a value of 1 printed to the screen. After line 8, flow of control again skips the definition of the function until it's needed. When the function inside is called at line 13, flow of control will move back up to line 9, where the function is defined, and proceed straight to line 11, where our third value of x is created and declared. Now here's where we may encounter our first counterintuitive result. Because this x right here has been created, and we then ask to print our variable x, which value of x is going to be printed? From the inside function, from the perspective of the inside function, the x on line 11 is a local variable, while from the perspective of the inside function, this variable x is more like a global variable. And so when this print statement is executed and it's looking for which x it ought to encounter, it's going to go to its most local definition of that variable, which holds a value of 2, and so a value of 2 will be printed to the screen here. At this point, once line 12 is executed, we've completed the call of the inside function, which completes the call of the outside function and returns the flow of control to line 16 of the code. Although we won't be able to watch the flow of control move between the lines the way we discussed while narrating, we will be able to see the print statements and determine the values of x that are printed by running our code. And you'll notice here that as we discussed, the first x to get printed in line 3 is the global x, which has a value of 0. We then bounce to our outside function call, define the new variable x with a value of 1 and print it to the screen, giving us this 1. Proceed to inside, call the inside function, declare this newest variable, this newest enclosed variable, x is equal to 2, and when we print this x, we go to the nearest definition of x to print that value to the screen.